What's up guys, welcome back to the channel. In today's tutorial, I'll be showing you how to build a simple long-range GPS tracker without internet using two Heltec V3 LoRa boards, Meshtastic and a Neo 6M GPS module. One board will act as the sender node with the GPS attached, and the second board will act as the receiver node where it will receive the coordinates from the other node over the mesh and show them in the terminal on our computer. So if you're into practical ESP32, LoRa, Raspberry Pi, and other embedded system projects, please be sure to subscribe to the channel. If you want the exact parts I use as well, or you want the full tutorial and more details in addition to the commands, please check us out on ShillehTek.com in the blog section to find out more. Now, let's get started first by quickly looking over the parts needed for today's tutorial. Then we'll wire up the nodes, the sender node to the GPS. We'll talk about Meshtastic, how to get it set up at a high level, and finally, we will print the live GPS coordinates on the screen. Let's get started. Okay, in order to follow along with today's tutorial, all you really need is two Heltec V3 boards. So we'll go over the wiring later, but here's the first board connected to my computer. We have a Neo 6M GT-U7 GPS module, as you see here. Breadboard, some jumper wires, and then we have a second LoRa Heltec V3 board. As you see here, this is the receiver node. So that's pretty much all you need. So just make sure you have a way to connect them to your computer, ideally both simultaneously at the same time, and that is all you need for the parts. Okay, so let's quickly go over the wiring for the Neo 6M to the first sender board. So we only need one GPS modules, and it'll be getting coordinates through this little antenna here. So make sure this antenna is faced up. Ideally, you want this pointed upwards to the sky and you want it to be outside. It does work inside, but this is kind of a weak antenna. Either way, just know that this is the antenna and this is the face of the antenna. And we just want to take 4 jumper wires, and I'm using a breadboard here just for organization purposes. We have 2 jumper wires for ground and power. So we have the power pin here, so this is the 5-volt pin, and then right here we have the ground pin. Let me just focus this here. And then bottom here we just have 2 other pins. So these are for serial communication. So we want to connect this to the TX pin on the GPS module, so we have the TX pin. Then we want to connect the green one here from the RX pin to, and this is GP20. So that is in more detail on the ShillehTek blog, but really just 4 jumper wires. Make sure you connect the antennas. So we have the antenna for the GPS, antenna for the LoRa, and connect it to your computer. Okay, so next thing we want to do is, after we wired our GPS module, make sure now we connect both LoRa boards to our computer because we want to install Meshtastic, which is the firmware we'll be running on both boards. So we could just do this one at a time. Make sure you go to meshtastic.org and you select Heltec V3 in step 1. Just do the version they have here, this version, the beta. And I can show you here specifically, you can find the board Heltec V3. It automatically selects this version, and then you can go ahead and flash and just select the port. So we can just select the port. So this is one of the modules. So I have both of them connected right now. And you can just do one by one and just flash the firmware. I already did that, and once the firmware is flashed on both modules, we just want to go to a CLI on our computer and make sure you have a Python virtual environment installed with the Meshtastic CLI. More of this on ShillehTek.com in the blog section, but really this is just a package in Python we can use to interact with the firmware on these devices. And the first command we're going to be running is we are just going to, first of all, activate the virtual environment that has Meshtastic CLI, and then we are just going to run this command. So this is the port pointing to the first module on our computer, and this port will be different on your computer. Make sure you find the respective port, and we're just going to set the GPS module enabled on the sender node, and we're going to tell it the pins that it's using, and then we're just going to reboot. So you can go ahead and click enter, and you should start seeing reboot on the device once this is running, and then you'll have GPS enabled on this node. Okay, so now that the first board is relaying its GPS coordinates on the network, we have to connect the second board, which is the receiver node, to this network so it can receive the GPS coordinates from the sender node. So in order to do that, it's very, very simple. We can just go ahead and get the channel URL of the first board. So we could just type this command in. Once again, we're using Meshtastic CLI. We're going to get the primary channel URL of the first board, and then we're just going to set that for the second board. So really all we have to do is we just have to do Meshtastic CLI again. And we have to select the port of the second board this time. So this is the receiving board. And then we're just going to select or set that channel URL and click enter. And that is all. We should be able to receive GPS coordinates. Okay, so last step here, we simply want to get the GPS module coordinates from the first board to the second board. And we just want to run a couple last commands. First of all, we want to get the sender ID, or the ID of the board with the GPS module attached to it. In order to do that, we just go ahead and run this Meshtastic command, point to the port, and get the ID. And then once we have this ID, what we want to do is I have this script here. It's on the blog at ShillehTek.com. This is kind of an overkill script. Honestly, AI wrote this, and pretty much what the script does is it helps us just parse the output from the GPS module and print it onto the terminal, just so we can see those coordinates more easily. And it does some other helper stuff. I believe you can also write to CSV if you're interested in that. It is in the blog on ShillehTek for more detail. But pretty much what we're going to do is we're just going to run this script. So we're going to call Python. We're going to point to the script, wherever it is on your computer. We're going to pass the port. Now the port here is the port of the receiver module, not the sender module. So we want to make sure this is the receiver. Of course, make sure both modules are connected to your computer. And then we pass in the sender ID, which is what we got in the previous step, and we can go ahead and run this. So this should start printing the GPS coordinates on the screen as the GPS sends it. Now I believe it sends it over a long period of spaces, so I think it's every 900 seconds. So in another 900 seconds, we should get another GPS coordinate. I believe there are ways to speedify the sending of the GPS coordinates. We're not gonna go over that, but as you can see, it just printed the GPS coordinates in the terminal, so things are working as expected, so that is awesome. And just to show you one last thing before you go, you can actually go to the GPS directly on the sender board, and you see there's a little button here. You can click through, and you can see that it's connected to 6 satellites right now, so that's cool. So you can always verify that things are working if you want to debug. And you can go to the GPS settings here on the sender board. You can see the last time it updated, the latitude and the longitude and is that the altitude? Yes, it is the altitude. You could see that is what is printed on the screen here. So about 200 meters, 88 longitude, 41.75 latitude, and 6 satellites. I think there's more than that. You can go around and play with this. I think you have all the tools you need now to start sending GPS coordinates over LoRa, that is without internet or Bluetooth, to your computer or wherever you want, really. So there you have it, everyone, for today's tutorial. I hope you got things working. As you saw, we were able to send GPS coordinates, so we created a GPS tracker without the need for Wi-Fi or Bluetooth. Pretty cool. These things are super low cost and they run on ultra low batteries, so you can have these things running for a very long time. I think there's many awesome practical use cases we can develop with these components. And if you are developing anything interesting, let us know in the comment section down below. I am really interested to see what you guys are building. If you have any questions or you want to see anything else on this channel, also let us know in the comment section as well. And if you simply enjoyed this tutorial or learned something new, do not forget to subscribe to the channel. Check us out on ShillehTek.com and stay tuned. I will see you guys in the next tutorial. Thanks for watching.